So today's lesson is on electromagnetism. So there's three learning objectives. Understand that an electric current in a conductor produces a magnetic field. Describe the construction of electromagnets. And then sketch and recognize the magnetic field patterns for a straight wire, which is the first one, a flat circular coil, and third, a solenoid. We have some right-hand rules with that. Okay, so what is electromagnetism? Well, it was first discovered in 1820 by Norwegian scientist Harald Ørsted, and what he did is he basically placed a wire across a compass, and then when an electrical current was passed through the wire, he saw that the compass was deflected. He went, ooh, that's a bit weird. And that was extended by Scottish scientist or physicist James Clerk Maxwell. Okay, and he showed actually there's a relationship between electrical current and magnetism. Okay, so basically you've got this electrical field being inducing or creating a magnetic field, and also conversely, magnetic fields can induce electricity or electrical fields. This is known as electromagnetic induction. So there's three types of fields that you have to be able to sketch. Okay, the first one is a straight wire. Okay, so in a straight wire, as you can see from the diagram there, we have the magnetic field basically consisting of circles, and the circles get closer and closer together as you get closer to the wire, because the magnetic field strength is getting stronger as you get closer and closer to the wire. Okay, you also see some arrows there, and you can actually predict the direction of the magnetic field, and that's where the right-hand grip rule comes in. Okay, so here is my trusty wire. Okay, if we take our right hand, okay, we grip our wire, and you will see that the thumb points in the direction of the electrical current. Okay, and that means that the direction of the magnetic field, the circular magnetic field, is going to be anti-clockwise. It's the direction our fingers are going around the wire. And of course, if you change the current direction, then the direction of the magnetic field will also change. Okay, and then we have the flat circular coil. Okay, and it's more pronounced, I guess, if you look at the plane view at what's happening. Okay, because again, we can use the right-hand grip rule and determine the direction of the currents. So in the right-hand side, no, in the left-hand side, sorry, in the left-hand side, get this right. In the left-hand side, okay, the current is going up, or I guess in this case into the out of the page. Okay, so that means the current is coming towards me, and if you grip, you can see that the direction of the wire, sorry, the magnetic field is going to be anti-clockwise. And then conversely, if it's going to go towards me, okay, there we go, going towards me, then again, it's now going to be clockwise, okay, because the direction of the current has changed. Now you can see on the diagram, you can work out if a wire is coming towards you because you have something like a dot, okay, a dot on the wire illustrates coming towards you. And if it's cross, then it is going away from you. And the way I remember this is arrows. Okay, so if the arrow is coming towards you, you'll see the dot of the arrow head, and if it's going away from you, then you'll see the cross of the feathers. Okay, that's how I remember it in 3 dimensions. And the last one is the solenoid. So essentially a solenoid is just a wire coil carrying electrical current, and we can basically see it behaves very similar to a bar magnet. So it has a north and south pole, for example. And the strength of the field increases with the electrical current and the number of turns of a coil. And this is one way we can build an electromagnet. If we put a magnetic core in there, say an iron core or a metallic core, which can get magnetized, so a hard magnet, you can basically let that metal then becomes magnetic, and you can pick up metal objects because it becomes magnetic. And you can increase the strength by either increasing the electrical current going through the solenoid or the number of turns of the coil of the solenoid. And we have a second right hand grip rule for poles, okay, for solenoids. And again, we're using the right hand. Okay, so basically what you do is you fingers are placed in the direction of the current flows around. Okay, so say it's flowing as it is in the diagram there. Okay, you can see that my thumb is pointing towards the north. And if we change the direction of the current, then it will again it'll now face the other way. That will be the north pole of that example. Okay, the thumb always points towards the north pole of the coil. Okay, so that's pretty much it for today's lesson. Enjoy doing the acrobats that are associated with the right hand rules, and I will see you for next lesson.